So elimination allows you to add the two equations. So basically you set them right on top of each other. And if there are opposites in terms of the values of the terms, if there are opposites, you can eliminate a variable, which is why it's called elimination. So we can basically get rid of a variable and then solve for the other one, as long as they are opposites, like 3y and minus 3y, or negative 2x and positive 2x. So you'll have opposites.
So you don't really add the equations together, you just put them next to each other and see if there's...
Yeah, but then you do add them. So ultimately you do, because if you added negative 2 and positive 2, you get 0, and that one goes away, and then you add the remaining ones to solve.
Then that would only be, you could only do that for one equation.
Correct. Well, for both. For one variable.
Yeah.
Yep. But then that gets you one variable, and then you just plug it in for your other one. Okay. If you need to, sometimes you won't be given two equations that have opposites right away. It's always nice when you do. But if you don't, you need to multiply in order to get those opposite terms that can cancel. Okay? Once you have two opposite terms, a negative and a positive, with the same coefficient, you combine the equations, so you add them, which will end up eliminating a variable. So then you'll just be left with x's or just with y's, which will allow you to solve for x or solve for y.
But don't you have to switch to another method then to solve?
You won't have to switch to another method, but what you'll do is you'll end up being able to see, like, oh, x equals 4, and then plug that x back in. Bless you. So solve, and then, like we were doing yesterday, plug back in that value to find the other variable. And remember, the solution will be an ordered pair. Bless you. All right, so this tells us to solve using elimination, so we're going to use this elimination method to solve. Here's our system. 3x plus 2y equals 4. 3x minus 2y equals negative 4. Now, if you were given this and you weren't told you have to solve using elimination, you would want to use elimination because we have opposite values, a positive 2y and a negative 2y. Do you see that? So what we do here is we combine these equations. We are going to add them. Because when we add, that whole y term is going to go away because it becomes 0. A negative 2y plus positive 2y gives us 0. And then we just add all the rest. What's 3x plus 3x? 6x. What's 4 minus 4? 0. Is that okay to have 0? Yes. Don't be like, oh, I can't do this. No solution. No, it's okay to have a 0. Then, to get x, divide both sides by 6. So what does x equal? 0. The x coordinate of our intersection is going to be 0. From here, now we just take the fact that x equals 0 and plug it back in to either of the original equations. I don't think one looks better than the other, so I'll just plug it back into the first. 3x plus 2y equals 4. And now I know that x equals 0. So I'll do 3 times 0 plus 2y equals 4. 3 times 0 is 0, so that goes away. And then we're just left with 2y equals 4. Divide by 2 on both sides. So y equals 2. So my ordered pair, because the solution is always an ordered pair, is 0, comma, 2. Does that make sense? So elimination is pretty easy, especially if you're given the opposites right away. it doesn't take a ton of work because you automatically get rid of one right away and then you solve for the other. This one says solve using elimination. What do you notice here? Is it going to be as easy as the last one?
Yeah.
No.
Not quite. We don't have given opposites. Could we change something in order to make opposites?
Is it possible to add 3y?
It is, but we want to get it to be 6y, right? So that we could actually eliminate. If we multiply, 3y by 2, then we would have an opposite, right?
Multiply -5 by
Correct. Or we could multiply -5 by -2 because we'd want it to become positive, right? I think it's going to be easiest to do this times 2.
Do you have to, so you just pull the 2 out of the hat to make it the same, right? But then
Correct.
to the other side, you have to do the same.
Correct. Okay, that's super important. Because we want this 3y to become 6y, we need to multiply it by 2. But we can't only multiply one part of the equation by 2. We must multiply the entire thing by 2. So here's what we're going to do. I'm going to multiply it by 2 each term. So 2 times -10 gives me -20x. So we're basically distributing this, right, to every single term. 2 times 3y gives us plus 6y. 2 times 1 is 2. Now I have a system where I've got my opposites. And now I can do my elimination and start solving. So I'll draw my equal sign. I will combine the terms. Okay, be careful, because this seems to keep happening to us. What's -5x minus 20x?
-25.
Yes, very good. -25x. Okay, these become 0, so we get rid of that y. So -25x equals 23 plus 2 is 25. Then divide both sides by -25. And what does x equal? -1. -1. -1. Now we know what x equals, so we go back to our 2 original equations and plug in x. I'm just going to use this one because I can see it still. -10x plus 3y equals 1. And I'm going to plug in a -1 for x since we just solved. You guys with me so far? Okay, so then we get +10 plus 3y equals 1. And then we're going to solve for y. So subtract 10 on both sides. 3y equals -9. Divide by 3. And y equals -3. My ordered pair will be -1, -3. Elimination. This is what you never want to see, but once in a while you will see it. It's a 9. 9x plus 2y equals 39. 6x plus 13y equals -9. We have no opposites here. And we also can't easily manipulate one equation to get an opposite. Do you see that? So we need to manipulate both equations so that we have a set of opposites. So what if I do something like, let's do maybe, let's get this to 18. Let's get this 9x to become 18x. Because I can see that if I can get 18 and -18 with my x's, then I can eliminate. Do you guys see that? I'm going to have to mess with both. Gentlemen. both equations in order to be able to eliminate.
Yeah.
Okay, so let's start with the first one. Let's multiply. Remember, we have to multiply every term, not just the one. So we get 18x plus 4y equals 78, I think. No.
Yeah.
Yeah?
Yeah.
Okay. Now, what should I multiply this one by in order to get a negative 18 in my x position? Negative 3. Okay, and as I did before, every term by negative 3. So negative 3, so negative 18x minus 39y equals 27. Now I can eliminate, right? Now I have this set up so that I can do my elimination and solve. So I'm going to give you a second to do this. See if you can solve this one now that we have it set up to eliminate. What should we do? Plug it in. Plug in that negative 3 into one of the original equations. So go back to one of these, not to one of these. Why do we not use those?
Because that's like that's what we had to use to find.
Yeah, and if we made a mistake, then we're going to continue our mistake. So always go back to the original. So it doesn't matter. I'm going to use, I think I'll use this one because the numbers are smaller. Well, not really. Oh, well, I'm going to use it. 6x plus 13y equals negative 9. And now we know that y is negative 3. 6x plus 13 times negative 3 equals negative 9. I know, I picked the wrong one. 6x minus 39 equals negative 9. Add 39 to both sides. So 6x equals 30.
So it's 6.
It's what?
X equals 6.
X equals, yeah. X equals 5. And then my ordered pair, because that's how I must give my answer, is 5, comma, negative 3.
Do you have a worksheet similar from last night to do this on?
Yes. Okay, word problem, just so that we can write a system of equations and be able to solve it if necessary. It says a business buys 7 large vans and 5 small vans. We want to give an X and a Y value to each of these. Let's call the large vans X and the small vans Y. Okay, location A receives 5 large and 2 small vans for a total of $235,000. Location B receives 2 large and 3 small vans for $160,000. What is the cost of each type of van? How would we set up a system of equations to solve this? Zegan.
The first one would be 7x plus 5y.
Yep.
And the second one would be 2x.
Actually, we're going to get more specific. Yes.
If we're on the test, does it, it's kind of a dumb question, but does it matter which one you choose to be X and Y?
It does not matter. So that's a really good question. She asked, like, what if we had put Y for large and X for small? It doesn't matter because when you write the equations, it's going to line up so that you get the right answer, no matter which one you choose. Okay? This part, this X and Y, the 7 and the 5, actually break down into these two. So we actually are going to use these to write our equations. Location A and location B. So give me an equation for location A.
7x and 5y.
Look more specifically. What's location A say?
5x plus 2y
Yep.
equals
Oh.
235.
Good.
Yeah,
Good job. Okay, what about location B? What would our equation be for location B?
2x
Yep.
plus 3y
Good.
equals
Good. 160. Yep. Ooh. 160,000. From here, we can solve using any of our methods. This is going to be one of the ones that's going to be a pain. We'd have to change both of the equations in order to get opposites for elimination. But we could also use substitution or graphing to solve. Okay? All right.